and welcome to Graphical Inequalities. Just before we start, a reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So what we're looking at today are inequalities shown on graphs, and in each case we need to first of all identify the name of the line which is drawn, and then decide which part are we interested in. Are we interested in the part that's shaded or the part which is unshaded? So the first thing here is we need to name the line which is the absolute end point of the shading. And so it is a straight line going straight up through x. Now that means that the line is x equals 1. But x equals 1 is not an inequality. What we are looking for here is the inequality shown by the shaded region. And so in this case, what can we say about all of the values of x? Well, in this case, everything on the left hand side would be less than or equal to 1. Now what you also notice is it was a solid line. The fact that it is a solid line means that it can include that value, and that is why it is a less than or equal to. In the second one we have a dotted line, and so because it is a dotted line, that is the indication that we do not include it, and so we don't want the equals to sign in our inequality. In this case, the line is a straight line going straight across, and it's going through the y-axis, and therefore it is a y line, and it's going through at -3. Now in this case, again, we are dealing with the shaded area. So which part of the graph is shaded? Well, that is everything below -3, and therefore this is the inequality y is less than -3. If we try it again here, same idea. We just want to first of all identify the line that has been drawn. And so in this case, it's going straight across and it's going through -1 on the y-axis, and therefore it's a y and a -1. But again, we are looking at the shaded region. What can we say about all of those values? Well, all of those values are less than -1 because we've got -2, -3 and so on. And it is a solid line, and because it is a solid line, we also want our equals to symbol. In the fourth question, the line that we are using is this one here. Now normally we would just call this one the y-axis, but we can't use that when we are describing an inequality. So what is the name of this line? Well, it goes through the x-axis, and therefore it is an x line, and it goes through at 0. So this is the line x equals 0. But in terms of the inequality, we are dealing with the shaded area. And so the shaded region, what can we say about all of those values? Well, all of those values are less than 0. The line that we have is solid, and therefore once again it is a less than or equal to inequality. So next we're going to look at some diagonal lines, and in this case, once again, the first thing we want to do is identify what the line itself would be called. And so in this case, we're dealing with this diagonal that is going corner to corner to corner. Now, what you should be able to recognize here is that this is the line y equals x. Each y coordinate is exactly the same as the x coordinate, and so this is y equals x. But again, what we're dealing with here is we're looking at the values in the shaded area. And so in each of these cases, is y greater than the x value or is it less than? So all I want to do here is I just want to choose any point which is in that shaded area. Now let's have a look at this one here. So this is the point 4, -4. Now in this case, if I were looking at the y coordinate is -4. If I compare that with the x coordinate of 4, it is clearly less than. And so the shaded area here is y is less than x. The line that we had was solid, and therefore because it is a solid line, it will be less than or equal to. And that is because if we were right on the line, that would be the coordinate 2, 2. In that case, y is actually equal to x. If we have a look at the next one, well, the line is going in the opposite direction. So that is a negative. So we could just look at this and say, well, we know that this one is y equals negative x. But there is another way of reading this actually. If we have a look at each of the points here, so I've got negative 4, 4. This one I've got negative 2, 2. Here I've got 3, negative 3. There is another relationship between those two values. If you add together the two coordinates, what do we get? Negative 4 plus 4 is 0. Negative 2 plus 2 is 0. 3 plus negative 3 is 0. So I could actually call this one x plus y equals 0. It would mean exactly the same as y equals negative x. And in terms of graphical inequalities, we often write them like this. So we combine the x and the y on one side of the inequality sign. But the question here is, again, in terms of the inequality, what does this shaded area show? Well, again, choose yourself a point that is in the shaded area. I have 5, negative 5. If I add 5 and positive 5, sorry. If I add 5 and 5, I get 10. Well, 10 is greater than 0. And therefore, this section above the line will be x plus y is greater than 0. The line itself is dashed, and therefore we do not want the equals to sign. We just want to leave this at x plus y is greater than 0. If we'd used the original format, it would have just been that y is greater than negative x. Okay, so what we're going to do next, we're going to just try and find the gradients of the line in order to name that line. So the first thing I'm going to do is I'm just going to choose myself two corners of squares which are on that line in order to create a little triangle. And to find the gradient, I want to do change in y, which is 3, divided by change in x, which is 3. So that is telling me that the equation will be y equals x. And then what is the intercept? Well, it crosses the y-axis at 2, so x plus 2. But y equals x plus 2 is the name of the line. What I'm interested in is what this shaded area is representing. And so in this case, all I need to do is again choose myself a coordinate. And I'm actually going to go with 0, 0. And if I use 0, 0, is it true that 0 and then 0 plus 2, what can we say about those two things? Well, 0 is less than 0 plus 2. And therefore, that is the sign that should be in between my two parts of the inequality. It is a dashed line, so because it's a dashed line, I don't want to put the equal to line underneath. It is just y is less than x plus 2. Moving on to the second diagram, well, if I were to look at this one, it is a negative line. So I know straight away that my gradient must be negative. And again, all I'm going to do is choose some points here. My change in y, well, that is negative 3. My change in x is 3. So the gradient this time, that means it's y equals negative x. And where does it cross the y-axis? Well, it crosses at negative 3. So negative x, take away 3. Now, if you wanted to rearrange this so that we didn't have a negative involved in terms of x, well, we could just add x to both sides. So we could say that this is x plus y equals negative 3. And all I want to do now is choose a point on the graph, and I'm going to go with 0, 0 because it's the easiest one to do. 0 plus 0 compared to negative 3, well, 0 plus 0 is 0. That is greater than negative 3, and therefore the sign in my inequality should be a greater than. The line is solid, and therefore we should add the line underneath as well. And so the answer to this inequality is x plus y is greater than or equal to negative 3. And then again, we're doing exactly the same again. We want to find the name of the line first before we then start thinking about the inequalities involved. And so it's going to be in the form of y equals mx plus c. All I want to do is choose myself two points on the corner of squares. And there we go. And so my change in y, well, that is 6 up and it's 3 along. So my gradient in this case is going to be y equals 2x. Where does it cross the y-axis? Well, it crosses at 1. And so this line is y equals 2x plus 1. But again, I want to know what the shaded area is representing. Well, the shaded area, if we choose, once again, a coordinate on this line, in this section, let's go with 0, 0 again. 0 to lots of 0 plus 1. What is the comparison between those two? Well, 2 lots of 0 plus 1 is 1, so that is greater than 0. And therefore, the inequality should be the same. And then the question is this a less than or equal to, or just a less than? Well, it's a dashed line, so it remains as y is less than 2x plus 1. In the second of the questions here, again, same thing. We want to find the gradient of the line first by making ourselves a triangle. That is 3 and 1. So that tells me y equals, and then we do need to just notice here, this is a negative 3, it's a negative gradient, so it's negative 3x. Where does it cross the y-axis? Well, it crosses at 2, so that's negative 3x plus 2. And again, choose yourself a coordinate. Let's go with 3, 2. And so, y is 2, x is 3. Negative 3 times 3 is negative 9. Plus 2, well, that is negative 7. And so, 2 is greater than negative 3 times 3 plus 2. And so that is the same up here. And then it is a solid line, therefore we should have an equals to sign in there. Now again, you may rearrange this if you want to get rid of the negative in the x's, so it'll be y plus 3x is greater than or equal to 2. That is exactly the same expression. And finally, we're going to look at actually marking the inequalities ourselves and showing the region which satisfies all of them. So when we combine all of the inequalities together, finding a single region which satisfies everything that we've been told. Now, in order to do that, what we're going to do is we're going to take each inequality at a time. So the first one is y is greater than or equal to negative 2. Now, because this is a greater than or equal to, I know that that must be a solid line, and it's y greater than or equal to negative 2. So that means it crosses the y-axis at negative 2. Now, what I'm actually going to do here is I'm going to do the opposite of what we've just done in the previous questions. I'm going to shade the section which doesn't work. So I'm going to shade out the bits which I don't want. So everything below negative 2 I don't want in this case. Then its x is less than 1. Now in this case it will have to be a dashed line because we have been told that it's less than 1 but not less than or equal to. And so we draw in our dashed line at x equals 1. And again, I want to get rid of the bits which don't satisfy my inequality. And so that will be everything where x is greater than 1. And then finally, I want to draw x plus y is less than or equal to 2. Now all I want to do here is I need to start off with a couple of coordinates in order to find x plus y equals 2. And so if x is, let's say, if x is 0, what would y have to be? Well, y would have to be 2. So 0, 2 would be one of my coordinates. 0, 2. If x was negative 2, what would y have to be? Well, that would have to be 4. And so negative 2, 4 is another one of my coordinates. Now in this case it's a less than or equal to, so again we're back to a solid line this time, and the solid line is going to have to go through the 2 points that I've just drawn. And let's just get rid of that, there we go. So we draw a solid line, and we were told that it had to be less than that value. So we want to get rid of anything which is greater than, and so that would be everything above. And so what that means is we can now see a clear area which is satisfying all of our inequalities. It is everything left here. And so I'm calling that R, because that is the name for a region which satisfies the inequalities. So we'll do the same method again, this time for the three inequalities that x is greater than or equal to 0, y is less than 3, and y is less than or equal to 2x plus 1. So the first one is a greater than or equal to, so again that is a solid line, and x is greater than 0, so the line must go through x at 0 and it will be a solid line, and we want x to always be greater than 0, so I'm going to shade out everything which does not work, which would be everything to the left. Y must be less than 3, and so for y to be less than 3, I'm just going to go back to my dashed line, and if y is going to be less than 3, well, that would be going through the y-axis at 3 with a dashed line, but we want to get rid of everything which doesn't work, so again this time anything above that line we do not want. And then y equals is less than or equal to 2x plus 1. Well, I'm going to begin with the line y equals 2x plus 1, because if I do 2x plus 1, I know that it crosses the y-axis at 1 and it goes up 2 for every 1 along, and so I can just draw that line straight in without forming any coordinates. It would look like that, and in this case y has to be greater than 2x plus 1. And so what I'm going to do here to decide which side of the line I'm interested in, I'm just going to choose a coordinate. Let's choose 3, 1. So what that means is 1 is y and x is 3. So 2 times 3 plus 1 is 7. If I compare 1 to 7, well, 1 is less than or equal to 7. And therefore, this section where 3, 1 is part of what I want. And so I'm going to get rid of the parts that I don't want. I don't want these ones. And so I need to get rid of everything which does not satisfy the three inequalities. So the section I am interested in is this one. This would be R. And so we end with the exam question. It came from the Edexcel paper in November 2017 and it was on higher paper 2. And we've been asked that on the grid we shade the region that satisfies all of these inequalities. Y is greater than 1, x plus y is less than 5, y is greater than 2x, and label the region Y or R. And so first of all, let's just have a look at the first inequality. It's y is greater than 1. Now because it's greater than 1, that is just going to be a straight line, and it's going to go through the y-axis at 1, but it is a greater than, not a greater than or equal to, so it is a dashed line. And in this case we want to shade the sections which satisfy the inequality. Therefore this time I'm going to shade in the bits which do work. So I'm going to shade in everything where y is greater than 1. In the next section we've got x plus y is less than 5. So in this case I want to be thinking about x plus y equals 5 in order to draw the line. And so I just need to think of pairs of coordinates which would work to make x plus y equal 5. So we could have 3 and 2, we could have 1 and 4, we could have 5 and 0. And we'll just plot each of those points. So 3, 2, 1, 4, 5, 0. And then we'll join them together with a straight line. And again, it is a less than, so it's a dotted line again. So a dotted line just going through each of those points. Now in this case, it had to be less than 5, and therefore we want all of the points where it's going to be less than 5. So I'm just going to change colours, and this time it's going to be everything underneath that line. And so you'll start to notice we have now got a section which is overlapping. So everything around here, above one line and below the other, is now an overlap. So they are satisfying two inequalities. Then finally, y is greater than 2x. Well, that is the same as the line y equals 2x. So that is just a gradient of 2, but going through the y-axis at 0. And therefore that is the line here. This is y equals 2x, but we need y to be greater than 2x. And so in this case, that means we want everything above the line. And so if we start looking now at where all of those overlaps occur, well, it is this section here which overlaps for everything. And therefore the section, we should make it really clear which section we are dealing with. It's this section here, and it's that section which we are going to call R. It satisfies all three inequalities.